Hey guys, Zong here, back with another math video. Today we're going to be doing a problem that I wrote. I think it's about AMC 12 level or maybe AME level, I'm not really sure. But try to solve it if you can. Pause the video to read the problem, and I will go into the solution right now. So, let x and y be complex numbers both with modulus 1 and y equals x to the fourth. Quick tip, whenever you see some complex number question with modulus and a complex number to some large power, you almost always want to convert these complex numbers to polar form. Now what is polar form? Polar form is essentially, let's say x is a plus bi. If we draw the complex number plane, plot this. That's our complex number right there. The modulus, or the magnitude, is going to be the length of this line. So let's denote that by r. And the argument, which isn't stated here, the argument is going to be this angle, theta. Now, when converting this to polar form, we simply have to denote x as r cosine theta plus I sine theta. And why does that work? Well, since r is the hypotenuse of this essentially right triangle, cosine theta times r is going to be this. And sine theta times r is going to be this. So it's essentially this multiplied together is this thing multiplied together is a, and this thing multiplied together is b. And it makes it very easy to raise this to some arbitrary power, because de Moivre's theorem, which I can't spell so I'm not going to say it, de Moivre's theorem states that x to the arbitrary power n is equal to r to the n times cosine n theta plus I sine n theta, which makes it very easy to take some complex number to the fourth power, right? Because this is an actual number, not a complex number, so you can easily do that, and this is just an angle. Which is why when you see a complex number raised to a large power and modulus, which means magnitude, you always want to convert to polar form. So let's try to denote both x and y in polar form. I'm going to denote x as, and we know modulus 1, so r is just going to be 1. So we're left with cosine. Now I'm going to use theta over 2 plus I sine theta over 2, and I'm going to explain why I am using theta over 2. And y, if we use de Moivre's theorem, we just plug in 1 to the 4 is 1, so it's going to just equal to cosine 2 theta, since you multiply this by 4, plus I sine 2 theta. And you can see why I use theta over 2. It's because I don't want to deal with the 4 theta. And I know my formula for theta over 2 and cosine 2 theta, so it all works out. So, if both the real and imaginary parts of component y are non-zero, find y given that ry plus I squared. Okay, so the real part of y. So the real part of y is cosine 2 theta. So cosine 2 theta. And the imaginary part of x is this. So sine theta over 2 squared is equal to 1. Okay. Hope you know your trig identities, because you're going to need them. Cosine 2 theta is equal to 2 cosine squared theta, and sine theta over 2 is equal to square root 1 minus cosine theta over 2 squared to the 1. Alright, you guys can simplify this on your own, but I think after simplification you essentially get 4 cosine theta squared minus cosine theta minus 3. And of course, this is just a quadratic equation. You can just substitute a in for cosine theta and you get a quadratic equation. And the two answers you get for cosine theta are that cosine theta is equal to 1 or negative 3/4. What happens if cosine theta is equal to 1? Well, if cosine theta is equal to 1, it's probably going to be on the plane. It sort of looks like this. So if cosine theta is 1, the theta is essentially 0, right? So cosine 2 theta, which is cosine 2 times 0, is still 1. So with y, since y's real part is cosine 2 theta, it's just going to be 1. Well, basically what happens is one of these is 0. And it says if both the real and imaginary components of y are non-zero. If cosine theta is 1, after you calculate it all out, one of these is going to be 0. It's just going to be either a real number, I think it's just a real number, or an imaginary number. So that doesn't work. So actually we're just left with cosine theta is -3/4. And the rest is pretty easy. You just find this, right? So we need to find cosine 2 theta and sine 2 theta to get y. So cosine 2 theta is equal to, as we established, 2 cosine squared theta minus 1. Oh, I made a mistake here. I'm sorry. That was a bad mistake. Minus 1 there. Sorry. You should have caught me. I was just testing you. Yes. So that's equal to, so 9/8 minus 1, which is equal to 1/8. So the real part of this is 1/8. What's the imaginary part of this? Well, you want to be careful. I bet you're thinking, oh, the magnitude is just 1, so I can just do like a right triangle and just be like, oh, this is 1, this is 1/8, so I can just find this. You want to be careful because this can also be negative. This can also be negative and it'll still work. And actually, in this case, it is negative. So what you sort of want to do is actually just want to manually do this. So sine 2 theta is equal to cosine 2 times cosine theta sine theta, and you can find sine theta using the right triangle thing. And actually what happens is this is actually negative, which is why you want to be careful. So you can just, I'll trust you guys to solve this by yourself, finding sine 2 theta given cosine 2 theta. And your final answer is just going to be 1/8 minus 3√7 over 8. So that's your answer. So I hope you enjoyed this problem. Yeah. So good luck on AMC 12 and AME. You're gonna do fine, or AMC 10 if you're taking AMC 10. I'm taking AMC 12 this year, and I'm gonna do horrible. I'll see you next week.
So 3/19 times 2 is 6/19, plus 5/19 is 11/19. Mainly because when you square this number, you're essentially doubling the exponent. And when you multiply it by this number, you add the exponent